for the sake of some of this material, it may find its way on the final exam, so that's there. And I'll post these slides as soon as I'm done talking this file up on Facebook. Okay, what we're going to talk about is, yeah, this record, general purpose I/O right there. And there, I'll be honest, it's been a while. I've never done this on the Raspberry Pi 3. I did it on the Raspberry Pi 1 several years ago. I haven't used Raspberry Pi in class for a while, so that's there. So, okay, general purpose I/O is just a generic pin that you can control. It's an I/O pin, and now as you can see, he's showing pictures that there. This looks like a Raspberry Pi 2. That there, and the only reason I can tell is it looks like it's got 40 pins on it. That there, but you've seen the Raspberry, you've seen these pins on that there. The connector has different types of purposes. We're just going to turn on LEDs on and off today. We also have the I2C interface pins where we can connect to our hardware modules, you know, such as digital temperature sensors, accelerometers, various sensors we can connect with the I2C. That's there. The SPI is very similar for, you know, different types of devices right there. The I2C is similar to the CAN interface, which is used for a lot of automotive purposes out there. But these are two serial protocols used to connect the microcomputer to a different IOs. We're not, unfortunately, this class, we're not going to have time to play with those out there. We're just going to use the general purpose pins right there. And there's also a serial RX and TX for serial communications if you want to talk to other computers or use a different type of monitor or something along that line. That's there. So that's there. General purpose IOs that there can be used to connect to both digital outputs and inputs. You define them as an input or output when you set them up. You did some of that with the 8051. That's there. Now, the important thing here is that it uses the 3.3 as its high, same as the 8051 actually that you use that there. It can detect whether pin is low if they're activated. Now, one of the things that's fairly important is that the Raspberry Pi is not necessarily 5-volt tolerant. So if you have inputs, you should use 3.3 as your high right there. This is the 26 pin that right there. Each pin's got various purposes. It's got two 5 volts. And let me not use this one. Let me minimize this and let me bring up this is the 40 pin. Now I can't draw if I hit the draw button right there. So it's got, again, the same two 5-volt pins right there. It's also got a 3-volt power pin. We're going to use a 5-volt today, one of these 5 volts right there on pin 2, right there. It's also got a ground. And then we've got these GPOs, 14, you know, through 18 here. And again, you see all these pins are labeled with we've got ground spread out right there. There's multiple grounds. This is the 40 pin connector. This is what's on the Raspberry Pi 3. Right there. It's also got the secondary functions of these pins highlighted here in gray. So, in other words, if I want to use a pin 3, if I need an I2C interface, I can use pins 3, 5, 3 or 5. If I want to use SPI, I use 19, 21, 23. If I want to use IC squared with an EEPROM, that there, which we haven't even talked about using an EEPROM with this particular device, but we could write software in an EEPROM, store it, and have it boot up and run the code from the EEPROM, which is similar to what the 8051 does, only it's an external EEPROM right there. So we also have here's our TX0, and where's TX1? I don't see it there. There should be a second serial port. Well, maybe it doesn't have it. I don't see the second serial port. Does anybody see it in front of that there? They may have taken it out because not very many people use that anymore. It might have been on the, that's there. So if you look at the old 16-bit that's there, they've added a second SPI. The SPI was added, and that was more general purpose IOs at there. So all we're going to do today is we're going to where's my OneNote? OneNote. Up there. Okay, all we're going to basically doing is we're going to go for 5 volts, and pardon my handwriting here. That's on the Raspberry Pi. I'm going to say Raspberry Pi pin 1, pin 2. I think it's pin 2. And as I said before, my handwriting is not there. We're going to go from that. We're going to go through an LED right there. Right there. We're going to go through a 330 ohm resistor right there, and then we're going to go back to one of the general purpose I/O pins right there. That's all we're going to do right there. That's the extent of our wiring. Now this is called syncing the load. When we refer to syncing the load, it means that we supply the 5 volts from a 5 volt source. You know, we're using the Raspberry Pi as our 5 volt source right there. And we're taking this pin low to turn the LED on, that there, and high turns it off. And my handwriting has a lot to be desired. You can see why I'm not doing a lot of lecturing, trying to use my handwriting. That's there. So the handwriting, my doctor says, might take 6 months to come back. That's there. You know, when I went to the neurologist Thursday, he said that I'm about 70% recovered, but the other 30% might take a while. And the 30% is clean walking, where I can walk normal. As you saw, I walked upstairs without the cane, and I can walk without the cane now, which is, I'm doing much better than I was. But the handwriting is a long ways from that there, and that requires fine motor skills in the hand, and that's why it's so slow. That there, he doesn't guarantee he'll come back completely. Okay, but that's what we're going to do right there. So again, let's go back to our reader here. That's there. So right there. Now, a lot of these instructions we don't need to do because they're already there. But if you get an error, then we'll have to connect to the internet and go get the library. The library should already be installed with that there on the that there. And this is that there. So experiment 1 is what we're going to be basically doing. Oh. Okay, is we're going to be basically controlling an LED. So breadboard, this I don't need that there. Now I wish we had this cobbler kit. We don't have the cobbler kit, so we have to just use the jumpers to jump to the board right there. I've got the jumper. You'll need a male to male or a male to female to do this jumper right there. So that's there. And again, the current controls from the anode. This is actually a pretty good little slide because almost nobody remembers which lead is which. And on the LED, there's a flat side, and that flat side equates to the line on the LED. That goes to the negative right there. I always remember the long lead goes to positive. That there's what I always remember. Now, that's there. So don't worry about testing the polarity. We'll just, if it's wrong, you just take it out and turn it around, okay? That's there. So there's the multimeter. We won't talk about the multimeter. There's our simple circuit right there. And we're going to be using, actually, I'm using the 5 volt here and a 330 here. Okay? So, right there. So this is the circuit which we're going to set it up. It doesn't matter since the LED and the resistor are in series with each other right there. This is called sourcing right there. This is the other way. So you have 2 ways of driving a load with a microcontroller. You can either source the load, which means that the general purpose I/O pin supplies the current, or you can sync the load, which the microcontroller supplies the ground. The preferred method of doing this is the syncing, because most microcontroller circuits and most digital ICs can sync far more current than they can source. Now, to be honest with you, with the Raspberry Pi, it doesn't make much difference since we're using it to supply the 5 volts right there. So this is a simple circuit right there. So basically, we're going to turn off on the LED, turn it off for 1 second, and we're just going to repeat forever right there. So this is the code right there. And this code looks like it's a slightly different format than what we did before. The main part of the code that you should worry about is that we need to import these 2 things right here. Right there. We need to report the RPI GPIO as GPIO right there. And that pulls in the library to talk to the general purpose I/O right there. Then we need to tell it to clean up, and this is a function call. We're making a function call right there. And mode right there, board, use Raspberry port pin numbers, and here he's using pin 11 right there. I closed that there, but oh, no, I didn't close it right here. It's there. He's using pin 11. Pin 11 is as good as any right there. Right there. That's general purpose. And I'm a little bit confused that there, you may have to check to see if you use pin 11 whether or not that shows up on pin 11 or pin 23. It should show up on pin 11 right there, as I recall. Right there. So, and then just simply, while true, I'll put a low. That turns, now this one here, his comment here is he's turning it off. If you wire it up the way that I said to wire it up, that would turn it on. So in other words, change this to a high and this to a low in order to get that accomplished. And then we've got, well actually, no, the low turns it on, yeah, that's there. Sleep, yeah, low turns it on, yes, low turns it on, where he says it turns it off here in the comments. Because he's making the assumption that he's wiring it this way. Right there. I'm saying wire it the other way. You could wire it this way, it's fine. You could do it exactly like this. That there. Only difference is is that if you're going to wire it this way, you have to go get 200 ohm resistors. Since I got 330 ohm resistors, you've got to wire it this way right here. You got to wire it this way, right there. Since we have 330 ohm resistors. So these two are reversed right there. So this is 5 volts, and this is our GPIO pin right there. So those two are reversed. So this is the bulk of the code right there. And then experiment 2 is running LCDs. We're not going to have time to go through that. We're just going to do experiment 1 right there. You will have to do the input though. So as you look at right there, and this is some example. We'll talk about this next week when I talk about the final project on doing the input. We may do a small little circuit where we just check the, connect the LED and push a button and it lights the LED, because you'll need to use you'll need to use input for the final project right there. And for the final project, what I'm going to have to do is I'm going to have to just give each group one of the boards, and you just keep the boards and work on the final project, along with the HDMI converter, but you'll have to supply your own phone charger, because that's there, because I'm going to take my phone chargers home. I need to charge my phone at night. I don't have, I thought I had extras, but I think I gave them away. Too many people burn up their phone chargers and say, do you have an extra? That's there. And yeah, I'm fairly generous. So, all right, I'm just going to turn it loose at this point. Go ahead and get the parts that's there. And I'm going to disconnect this. I'm going to post these slides up. I'm going to see if I can find a better set of slides that talks about the Python 3 directly with a bit better an example. I thought this example was cleaner, but this example is fine, because what this is doing is it's defining a function here, and then we're calling the function right there is what it's doing. So, I mean, you could follow this code exactly and it will work. Or you can stick it all in main and right there. So, that's it. Let me post I'm going to unplug this. Let me post these. Go ahead and get the stuff and start setting up. Let me post these slides on Facebook real quick. And where's my Ethernet cable? Oh, I didn't bring one. I can connect to Wi-Fi. The Wi-Fi works if I... And as soon as you get done, let me know, because I'm not going to do like last time. I'm probably going to be, I'm going to try to meet with Dr. Kyrell for a little bit. But oh, let me stop the recording.